Okay, there are three things that I'm gonna calculate. Time to expire or expiry. Or let me do days to expiry first. If you take a date and you deduct the function today with no arguments, today is basically serial number Excel attaches to today's date. Of course, it's not a date format. Time to expiration in years. Take days to expiration divided by 365. Now, continuously compounded cost of carry. Because the rates that I put in are APRs, but the rates that go into option pricing are the so-called continuously compounded rates. Let me put these. Given APR, calculating R, which is the continuously compounded rate, negative, not negative, positive ln 1 plus APR times T divided by T. Remember, APR doesn't give you the interest rate over a year. APR divided by T, or in this case multiplied by T, gives you period interest rate. That's going to be ln1 plus cost of carry times time to expiry divided by time to expiry. That's it. Continues to come. Days to expiration divided by 365. Continues to compound its yield. Same deal. ln 1 plus asset yield times time to expiration divided by time to expiration. These are my intermediate inputs, calculations. Let me make it a bit smaller. Let's calculate D1. Since later on, I'm going to worry about multiple calculations, but right now, for template purposes, I'm going to write this whole formula in one line. Just follow me. ln spot divided by strike plus continuously compounded cost of carry minus yield plus 0.5 times volatility squared, the whole thing multiplied by time to expiration, and divide the whole thing after getting into parentheses, sigma times square root of T. I'll wait for you guys to copy. You guys are all done with it? You want to still working on it? I can't know unless you tell me something.
Yes.
Good?
Yeah, what was also the year for for
It's log of 1 plus the APR times rate, time, and the whole thing divided by time. For continuous to compounded rate, e to the negative rate times time is the present value of $1. That's how we find that formula. Doing it this way, you basically work with the APR. Excel automatically converts that to continuous to compounded rate for you. You don't have to worry about it. D2 obviously is D1 minus sigma times square root of time. Oh no, I don't have to worry about digits on these. N of D1 is norm S dist, that one. I'm going to call this N of X. I'm going to also need N of minus X. Nice thing about that is because of symmetry, that's 1 minus N of X. I could have separately calculated N of negative D1, but that's the function that calculates CDF of standard normal distribution, or so-called Z distribution. Now, these are my, I'm going to make them purple. All right. I got everything I need to calculate the call price. Remember what it was. This is e to the negative QTS. That's basically present value of the spot price using the asset yield, and this is the present value of the strike price. X negative asset yield times time to expiration times spot times N of D1 minus present value of the strike using cost of carry times the strike times N of D2. Is it all set?